Hello students, today we will discuss the area in Cartesian coordinate system, how to find out the vector area in Cartesian coordinate system. Let us consider a parallelogram PQRS. Suppose this is a parallelogram PQRS. In this parallelogram, let PQ is vector A represented by vector A and PS is represented by vector B. So we will find out the area of this parallelogram with the help of this vector A and B, and angle SPQ is theta. The angle between vector A and B is theta. Let us complete the diagram first. Now, in this diagram, if I run the vector product of vector A and B, then its magnitude is represented by vector A cross B is equal to AB sine of theta in terms of magnitude. So we can rewrite this as A B sine theta. In this diagram, if I draw a perpendicular from point S to the vector A and let it join the vector A at point N, then in triangle PNS, we know angle theta, vector B, this is perpendicular hypotenuse base, then SN is B sine theta in this triangle. So I can write it as B sine theta in separate. So from the diagram, A into this perpendicular B sine theta gives the area of parallelogram PQRS. That means we have find out the area of PQRS. Now, what is the direction of this area vector? Now we are moving from PQ to S, so we are writing A cross B. So then, with the help of this right hand first rule, I will keep my hand on the vector A and rotate my fingers towards the direction of vector B. So, and the direction of thumb will give the direction of area vector. As you can see the previous lecture of vector product of two vectors, then we have find out that A cross B is if A and B both lie in the plane of this board, then the thumb represents the third direction which is perpendicular to the plane. So then the vector S is A cross B and vector S is perpendicular to the plane. So I will denote it as vector S equal to A cross B. Now let us see if I have a parallelogram, another parallelogram with P1, Q1, R1, S1, and I suppose that this is vector A, this is vector B, and here I find out the area of parallelogram PQRS. Now I am just to find out the area P1, area of parallelogram, area vector. Magnitude will be same, but I am just discussing the direction. P1 parallelogram P1 S1 R1 Q1. That means I am moving from B to A, so let the angle between B and A is theta. So the direction will be inward. So I will keep my hand like this on the vector B and rotate my fingers towards the direction of A. Then the direction of thumb which is inward of this plane will represent the vector. So it's better if I denote it in this fashion, area vector S. So this is the simplest way to find the area in Cartesian coordinate system. So this is the simplest example how you can find out the area. So important thing is, are you calculating A cross B in this P, Q, R, S manner, or are you calculating from P1, S1, R1, Q1? Then the direction of area vector will be opposite. Okay. In the same manner, if you move from P to S to R to Q. Now we will discuss the area of closed surface enclosing a volume. That means we have a surface like this. Okay, so you can see we have 1, 2, 3, 4, 5 and 6 faces which enclose the volume and all the surfaces of area vector. So let us draw this diagram as. Let it be the origin O. Choose this axis as x-axis. This is y-axis. This is z-axis. We have unit vector I cap, j cap, and k cap along x, y, and z direction. Now I am drawing this particular diagram here. Suppose the dimension along y-axis dy, dimension along z-axis dz, and dimension along x-axis is dx. My drawing is not very good. So I have tried to make this diagram here. So here we have like this faces, let it be A, B, C, D, E, F, and G. So this faces A, B, G, and F, and this point is C, this point is D, this corner is E, and this corner is O. Okay. So now, from the diagram, if OC is dy, then AB is also dy. If OA is dx, then BC is also dx. If OE is dz, then CD is also dz. GB is also dz, and this FA is also dz. Similarly, AB is dy, FG is dy, ED is also dy. Okay. So if BC is dx, then GD is also dx, EF is also dx, and this is dx. I think we have completed all the axes. Okay. So now we will find out the area. So conventionally we have to find out the area of a surface in such a manner that the area vector. So conventionally we have to represent the area vector in such a way that the area vector should direct outward direction from the surface. So if we are choosing this surface, then the area vector should be point outward. And if I am choosing this surface, that means background OCDE, then it should be like this. It should be pointed outward. That means it should be normal to the surface but pointed outward from the surface. We are now completing this diagram. dy, dx, dy, this is dy, this is dx, okay. So this is dx, okay. So this is dz, 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 this is dx. In this way, we have completed the diagram like this. So, area of surface EFGB equal to area of surface OAB OCBA, and area of this face, front face and back face. So area of surface ABGF, this is ABGF equal to area of surface this back face. So this back face is OEDC, and now we are talking about this face and this face. Area of surface this CDGB equal to area of surface this face, this is OAFE. So we have to choose the area of surface in such a way that the area vector should point normal to the surface but in outward direction. So this is the convention while find out during the calculations or to find out the area of the surface which enclose the volume, like this example. So now first we see the area of this surface EFGB. This is EFGB. As I say EFGB, so I will move from E to F and then this E to D. So I have to calculate by keeping my hand on the EF face and rotate the fingers toward the ED axis. In this way, then thumb represents the outward direction. So you can see this is the diagram. So this point is E, this is D, this is Z, this is F. So I have EF into ED. So I have to choose in such a way that area vector should point in the outward direction. So I will keep my hand like this on this axis and rotate the finger toward this axis. So then thumb is in the outward direction, that is normal to the plane, this plane containing the area vector, containing the vector EF and ED. So along ED is dy, along EF is dx. That means, so that will be ds. This is the area vector ds. So this area ds xy is dx cap cross dy g cap. So it's better to write it as dx into dy I cross j. So I cross j is k cap. You can see the previous lecture on vector product. And then the area vector ds of this face. That means we are calculating the area OCBA. So we have to choose in such a way that area vector should point in the downward direction. So this is the face OCB and A. So I have to choose in such a way that area vector should point in this direction. So I have to rotate my fingers from dy to dx, dy to dx. In this way, the area vector should point in the downward direction normal to this surface. So ds yx, this is the plane yx. So it's better to represent area vector ds. So I have to remove this line so that you can imagine it is from here. So you are looking like this. ds yx is dy j cap cross dx I cap. So it will be dx dy j cross I is minus d cap. Here dx will be minus k cap into dx dy. So these are the area vector enclosing the upper surface and lower surface. Now we are interested to find out the area ABGF. So this is the face ABGF. Now you are looking, this is A, B, G and F. So we have to choose in such a way that the thumb will be in the outward direction. So this is dy to this is zx, along with zx is dz. Okay, so ds. Now we are finding out the area A, B, G, F. So this is the face. This is y-axis. This is z-axis. Then this is the convention to choose the area vector. It will be normal to the x. So normal to the yz plane. Normal to the yz plane. So it's better to write it as ds yz is dy j cap cross dz k cap. So it will be dy into dz, j cap cross d cap, j cap cross k cap is I cap dy dz. Now you are looking the back face on this face. So on this face we have to choose the area vector in such a way that it should point in the outward direction like this. So I have to choose from that face. Okay, so this is now like this. Then ds zy is dz k cap cross dy j cap. So it will be dy dz k cross j minus I cap dy dz. Now we are looking for the area of surface CDG. What is this CDGB? So this is this one is CDGB and OAFE. So this is OAFE. So I have to choose this area vector in such a way that it should point outward direction, and on this face it should be like this. So it should be like this. On this face it should be like this. So that means ds. So now we are looking at this face. This face is x z plane. So zx plane. So ds zx is dz k cap cross dx I cap. So it will be dx dz I k cross I is j cap. And similarly ds xz is dx I cap cross dz k cap. So it will be minus dx dz j cap. Okay. So finally we have to find out the area vector for all the 6 faces of this diagram. So these faces enclose some volume. So that's why we have entitled it area of the closed surface enclosing a volume. Now the total area of the surface enclosing this volume is ds. ds is ds xy plus ds by x plus ds by z plus ds zy plus ds zx plus ds xz. We have to do the sum of all the area vectors. So ds is that ds xy plus all these are vectors, area vectors, plus ds by x plus ds zx plus ds xz plus ds by x, xy by x, and this is by z, ds by z plus ds zy. So it's, we will substitute these values. ds xy is dx dy a cap minus by x is dx dy a cap plus zx is dx dz I cap, so j cap plus ds xz is minus dx dz j cap plus ds by z is I cap dy dz minus I cap dy dz. So finally the sum of all these is 0. So this is the area vector of the surface enclosing some volume. So this is 0. Thank you for watching. Please subscribe the channel for more lectures on classical mechanics.